Today we're going over polynomial functions. So the first thing we're going to look at is how to find the end behavior. And what I mean by that is, for example, if I have y equals x plus 2, then this would look like a line that's going through the y-intercept of 2 and has a slope of 1. So this would be a line similar to this, where the end behavior has the right side going up and the left side is going down. So we're going to look at just finding the end behavior for polynomials. So for this one here, we first look at the leading coefficient, LC meaning leading coefficient. And the leading coefficient is the number in front of your variable with the highest degree. And you look to see, is it positive or negative? And for this one, since it's a 1, it's positive. So when the leading coefficient is positive, the right side will always go up. So to find the left side, you look at the degree. And the degree is the highest exponent. So here the degree is a 1, and you look to see, is that even or odd? And 1 is odd. If the degree is odd, it goes in opposite directions. The end behavior goes in opposite directions. So since the right side goes up, because the leading coefficient is positive, then the left side will go down because it has to go in opposite directions when the degree is odd. If we have y equals a negative x plus 2, then we look at, again, the leading coefficient and the degree. So for this one, we already know what this will look like. This has a negative slope. So it'll look like that. So you don't have to memorize these, you should just think back to what you know, which is, I know what lines look like, for example. So we'll look at the leading coefficient. The leading coefficient here is a negative. So when the leading coefficient is negative, the right side always goes down. And then we look at the degree. The degree is odd here because the degree is the highest exponent, which is 1, and 1 is odd. And that goes in opposite directions, therefore the left side goes up. This is for when the degree is odd, and if it's a positive leading coefficient as opposed to a negative leading coefficient. So next, we'll look at when the degree is even for end behavior. So for example, if I have y equals x squared, we already know that this is going to be a parabola shape facing up. So again, you look at the leading coefficient and you say if it's positive or negative. This one is positive because the number in front of x squared is a 1. Then you look at the degree, and the degree here is a 2, so therefore it's even. So again, the right side, when the leading coefficient is positive, then the right side goes up. And when the degree is even, it's going to have the same end behavior. So since the right side goes up, the left side also goes up. If we have y equals negative x squared, again we look at the leading coefficient, and in this case the leading coefficient is negative. So the right side will automatically go down when the leading coefficient is negative. And then we look at the degree, And the degree here is a 2, which is even. When it's even, it's the same. So the left side also goes down. So that's how you find the end behavior of polynomials. So if we try some examples now, we can say, for example, if I have y equals 3x to the 5th minus 4x to the 4th. We look at the leading coefficient, and that is positive because it's a 3. And we look at the degree. So just by knowing the leading coefficient, we know that the right side is going up. Then we look at the degree. The degree is 5. So that's odd. So when it's odd, when the degree is odd, it's opposite directions. So the left side will go down. So the end behavior is down, up. Some other things we need to look at for this section is classifying it by degree and by number of terms. So let's say that the degree is 0, 1, 2, 3, 4, or 5. We'll look at the name that we call that. And then we'll write an example. We'll say the number of terms. And the name using the number of terms. Okay. This is the degree name. So the degree name, if you have a highest degree of 0, that's called a constant. For example, we can have y equals 2x to the 0. But anything to the 0 is just 1. So therefore this is just y equals a 2. So the number of terms here is just one term, and we call that a monomial. If the degree is a 1, we call that linear. For example, y equals x plus 2. So this has two terms, x is a term and 2 is a term, and we call that, when it has two terms, a binomial. If it has a degree of 2, we call that a quadratic. For example, y equals x squared plus x plus 1. That has 1, 2, 3 terms, and we call that a trinomial. If it has a degree of 3, then we call that a cubic. For example, we can say y equals x cubed plus x squared plus x plus 1. That has 1, 2, 3, 4 terms. And then after trinomial, we just call this a polynomial with 4 terms. If it has a degree of 4, we call that a quartic. For example, y equals x to the 4th. That only has one term here, and again we call that a monomial. And finally, if we have a degree of 5, we call that a quintic. For example, y equals x to the 5th plus 1. We gave that 1, 2, 2 terms, and we call that a binomial. So let's use all of this and try an example with classifying it. So let's say, for example, we have a polynomial, which is just the sum of monomials. Let's say we have y equals b times b minus 3 squared. So first we have to write it in standard form, meaning highest degree to lowest degree. So we're going to have to multiply out b minus 3 times b minus 3 because it's saying that we have two of them. So we'll FOIL this out, bringing down the b here, and then we'll go first, outer, inner, and last. Combining like terms, negative 3b minus 3b is a minus 6b. And then we have to distribute in this b out here, and we get b to the third minus 6b squared plus 9b. So if we want to classify it by degree, this is a cubic. And classifying it by the number of terms is 1, 2, 3 terms. So it's a cubic trinomial.